You want to do an opening moderation so I can come back to the stage again? Sure.
Hi, my name is Xiu Chao from Columbia University Psychiatric Department. We have some. I have some simple housekeeping announcements. We are using during the talk. We're gonna use this pigeonhole system where you can post your question online, and by the end of the talk, I will get those questions, and you can actually vote for the questions. And perhaps I can pick some highly voted questions and can pass it to the speakers. And if you can see the right screen, there's a pigeonhole screen. You can see all the questions being posted real time. The URL is pigeonhole, pigeonhole.aat/AI4 Arabic number 4 H2 segmented. And yes, I feel like to have a proper introduction to our speakers. So our first session, the first speaker is Mr. Thomas Wiegand. Mr. Thomas Wiegand is a professor in the Department of Electrical Engineering and Computer Science at the Technical University of Berlin, and the director of the Department for AIAH, Berlin, Germany. He's a member of the German National Academy of Engineering and the National Academy of Science. He's a recipient of the ITU 150 award, along with Bill Gates and scientists, as well as multiple Emmy awards. And Mr. Wiegand has been really spearheading this focus group, AI for Health, along with the vice chairs. So I didn't see the title, but he will set up the stage and we'll be the first speaker.
Okay, thank you. So I would like to introduce the vice chairs that are present, and you can see from first glance that we do have a serious problem here. We are all male, and that is something that we are fixing. We are actively searching for female participation in running this. We have been, but we haven't gotten so far input like that. So please, if you happen to be a female and if you want to contribute, please come forward and talk to us. We'll see where we can go. So I would like to introduce to the very left Professor Marcel Salafé. He is a professor at EPFL, and my French is too bad to spell out EPFL, but I don't think EPFL needs to be spelled out, everybody knows it. And then I would like to introduce Samir Pujari from the World Health Organization. He is a vice chair also of the focus group. And I want to point out Stephen Ibaraki. He is the head of, he's at the ACM and head of Rats Capital, and also a vice chair of the focus group. So let me then start with my talk. Yeah. Okay. So you see, we already have received the logo. The logo shows the 17 sustainability goals of the United Nations. The third green one is the health one. However, health as a sustainability goal affects almost all of those sustainability goals, because health isn't everything, but everything is nothing without health, something like that. And so, next slide, please. Oh, there's a clicker. Okay. So, artificial intelligence for health is something I think you're all aware offers a big promise. It kind of brings you into this digital twin computer modeling mode for health problems. And it may help you to overcome quite a few issues and problems in this space. So, for instance, public and clinical health, early detection, diagnosis, risk identification, treatment decision support, self-management, improved outcomes. There are lots of things AI in health can help you with. So, I mentioned earlier, when we see these projects, and one of the biggest problems in the health space is the euphemism that is a space that is self-regulating. I've heard this euphemism quite a bit, and you heard from my biography, I'm a communications engineer. And your internet, your laptops, your mobile phones, they actually work because people have agreed to use standards. And this simple agreement apparently doesn't apply to the health space. Everybody in this system, and his brother, have their own clinical terms, and they have their own way of creating medical records. And you walk into hospital A with a set of symptoms, you get a certain diagnosis, and you get certain treatments, and you walk into another hospital where you get different diagnoses and different treatments potentially. And I have seen this not only between different chains of hospitals, but also within the hospital. So the whole standardization aspect is not that widely deployed in the health space. And we try to make a contribution, we try to create value. And we think that for worldwide adoption, for AI in health, for algorithms that solve data problems in health, we need some benchmarking. We need some method of assessing how good they are so that they are keeping their promise. And we then basically want to provide this value with this group. That May this year sounded like, yeah, sure, why not? That's probably doable, but it's actually quite complicated, as you will see. So we created the focus group. So the idea was born in May. The creation was done in July. And the format of a focus group is an ITU format. You could say for business development, where you essentially have a new topic and people can get together. You can give the structure to yourself. You can follow the rules. Some of them have to bound to the ITU rules, but some of them can be more open. And participation is open, and the whole thing can basically set itself up so that actually it works. And we had our first meeting at the end of September, and that was basically really the first meeting where we set up things and where we actually formulated a start. So next slide, please. So here's an example, a diagnostic and treatment decision support system where you have your clinical records, possibly text, images, laboratory results, center time series, and you're mapping them, for instance, to an ICD, or you're mapping it to an ICHI value. And what's this map? How good is this mapping? How functional is it? Is it really doing the task that you need in this space? So just a very small example. Next slide, please. So the benefits of the standardization assessment is that we want to assure some quality, and then that would give you adoption in practice. And you know how it is with data, with AI methods. The more data you have, the better it gets. So if your method gets adopted, there will be more data flowing into this method, and you can further improve it. So there's a potentially not spiral going into the right direction for your method. Next slide, please. So what happened at the first meeting 7 weeks ago? It was actually quite constructive. Everybody saw that we are onto something here. So the amount of non-constructive discussion was there, but it was limited. We basically set up the basic focus group operation and structure in order to be functional. And then what we did is we actually created 3 major output documents. One is a draft thematic classification scheme for the health problems we're working in so that they fit into the WHO classification system. The second one is a set of draft criteria of data to be accepted by the focus group, because we need to be really careful of data where we don't know the source, we don't understand where they are coming from, for multiple reasons. And the last one was a draft call for proposals, where you would ask people for actual use cases, benchmarking, and data. And I want to go into that very last one on the next slide. So we requested basically very openly and very, in some way, not so much structured information about the project title, organization, name and contact, overview of the project, what the impact it will have, what data are actually available for it, and what we would actually be testing in this context. And so the reason for having such an unstructured, more or less open call was that actually we still don't know exactly what precise things that we can be testing, but we wanted to have a glimpse at it. And so we were boldly throwing out this CFP, and thanks to, for instance, our public relations vice president, this thing got out. And we had like thousands of views on social media and everywhere else. So we, at the next slide, received 14 submissions. Can I have the mobile, this mobile microphone? So these 14 submissions, I think it makes sense to take the time to go through them. So the first one is a snake identification based on imagery. Sounds like, whoops. When I explain to people like we do snakes, they go like, whoops, snakes? Well, if you're bitten by a snake, sometimes you're in shock. What can you do? You might want to catch the snake, but if you want to catch the snake, you might be bitten again, more venom, right? So why not take a photo with your phone and go with that photo to the hospital, if you make it to the hospital. But then if you make it, well, here we go. We can really use AI to identify the snake that bit you, together with where it has bitten you, and together with the bite marks, and who knows. So we would basically, and that's a method that would support a health problem, because we will see more than 100,000 people per year die of snake bites. It's a real third, particularly developing countries problem in the tropics and in warmer regions. Not so much in New York City, I think, and not in Berlin. Yes, it's in the US a big problem. Mining medical data to understand Alzheimer's disease. That's also a topic that was brought to us. There seems to be several ways to detect developing Alzheimer's disease based, for instance, on the way you walk or you do certain things. Assessing breast cancer risk using imagery. This is a suggested project where you have a tissue sample and you get to the digital image of the cells of the tissue sample, and you need to identify the tumor cells, and you need to identify the lymphocytes and the position of the lymphocytes. The lymphocytes are relevant to the treatment decision and to your prognosis of this breast cancer. And identifying them and identifying their percentage, their location, is something that's currently done by a pathologist by looking at a picture on an average of about 10 seconds and say it's 10%. And it seems like a machine learning algorithm can do this much faster and much more precise. So this is a third project. Enhancing the efficiency of primary healthcare in developing countries is a big topic brought to us. Providing patients with a biometric identifier. That was pointed out, I'm not sure, I haven't verified it, but 1/4 of all babies in developing countries are not registered, not put into any register. You just don't have an identification. You don't exist. Then autism classification using brain imagery, monitoring vital signs to manage patients from suffering chronic diseases. Chronic diseases will soon be the major causes of death. So this is a big issue. Predictive models for substance abuse. Evaluating symptom checker apps. People are starting to use apps to, like, oh, it hurts here, what's going on? And to get an idea, because sometimes you just don't have the time to see a doctor. It's not as urgent, but you still want to know what it is. Or you don't have access to a doctor. 1.7 billion people on the planet do not have a bank account. But 1 billion of them have a phone. So they could have, and if you don't have a bank account, you probably also don't have good access to a doctor. So this might be a way to help them. But also in developed countries, waiting times for some doctors are really large, and you're waiting at the hospital and things get worse. So you're catching this additional flu at the hospital when you're waiting for this other problem, and these apps can really help you. Exploring HIV risks using targeted surveys is a suggestion, where people are, where it is the idea to find out whether or not people that are particularly endangered in catching HIV, how their behavior is actually affecting the probability that they are catching it, and whether there can be feedback towards their behavior. Identifying and monitoring depression in teenagers. This is also an idea where we would involve what they text on their social media app, because that is something that appears to be becoming clear when you develop a depression, that they're also expressing themselves there. An epidemiological approach to understanding depression and anxiety. Then skin lesion diagnosis using imagery. How many of you have a spot on your skin? You know it for a while and you just don't go to see a skin doctor because you say, nah, I'll do that next week. Right? So, and then one day it's too late, and maybe this thing can help you to do it right away. And the last, not least one, is reducing the risk of falling among elderly. It's a very big problem if you're old and you fall. I think this country has a federal judge that just fell, and some of you from that political spectrum are really worried about this aspect. But there are lots of environmental risks that are in your environment. The way you arrange your house, the way you arrange your processes in your life, that may or may not increase the risk of you falling when you are above 70 years old. 14 projects submitted here. Some of them are quite far down the road, where we have lots of data available, and we might just, go deeper down into them already. Some of them are merely suggestions, where it would say this is an important problem to work on, but we need data. But most of them do have a data source associated with them, or do point out the process to create those data. And we'll see what the focus group is going to do. But it could be that on Friday we are walking out of here with 10 active AI for health projects. Okay, move to the next slide. So let's look at the assessment framework, and I think Marcel will talk much more detail about it, but I'm trying to set the stage. So there are three parts to it. First is the collection of input-output data sets. We need somehow to figure out let me put it that way. A lot of health problems, the truth is not known, the real truth. It's human level medical expert performance that basically forms the ground truth in this space. And I think the best we can expect from an AI algorithm at this stage is that if it's as good as the human level performance, if it's better, well, that would be great. But and there are some cases where you could acknowledge, because some humans cannot take a human cannot take into account more than a certain amount of data. So then the second part of the data creation is also we also need to understand that when you test these algorithms, and if it's a mapping and you know all the input-output data, then you could just store the mapping, right? But that would not generalize to the next patient, to the next case. So we need to actually do this testing in part, or we need to do the testing with private data, that the algorithm, where the algorithm does not know the output. So this is a big challenge, having private data and public data available for a problem. Then we need to create metrics. We need to figure out what does good mean. In what sense is this thing good? And then we can evaluate the AI algorithms. And the idea is then to have an entirely open process. Everything is documented, and then have it also a report on this open process. From the point of data creation, the way it's created, to how we are creating reference data, how these are annotated over how we came to the metrics, and then what's the result. All that is supposed to be open, so it's very clear to those who then take this report to take it one step further. So a bit more specific on the data sets. So we want to gather data sets to test AI algorithm, and we want to have a clear source identification. There are open issues. One is reproducible reference data sets. Let me go to this example for breast cancer. At the moment, at the Charité in Berlin, there are 2 medical doctors annotating these cell pictures. So they are making a cross at the lymphocyte, and then they circle the cell area around, and then the whole certain amount of circles basically gives you the percentage of tumor-infiltrating lymphocytes. Well, one of them may be more, he or she may just make bigger circles, and one of them may make just smaller circles. Some of them may say, well, this actually would fall into that category, this falls into this category, and what if we gave these pictures to some other place, some other medical expert, does the annotation? Will they come up with the same result? It will be always different. You give it to different humans, it will be always different. How important is that difference between the annotations between those humans? Well, at the end of the day, we actually need to have a specification where these reference data, these assignments, these annotations can be reproducible. And then that way we can actually have this first step here. Then we have to have this test on data that are private. If they're not private, it's really difficult to figure out whether the algorithm actually cheated or really generalized to these unknown data. And one way of doing it, and we have received a submission there, is encryption, and do operations in the encrypted domain. So all those test data remain encrypted forever. And then, let's say if you have a big data set, how do you split it into
a portion that you make publicly available, so for people to understand and train their algorithm? And and what other parts you keep? Do you keep the probability density function representatives? Do you keep the support vectors? What are you keeping? What are you giving out? It's not clear, and so the first topic is still needs to be worked on, but for the second two topics we do have submissions. And we also should probably embark on those problems to also, in a generic way, suggest solutions. Then the creation of metrics. We need to compare the AI solutions to human-level performance, and we have to figure out a metric that is meaningful for the health space, for health experts. As a computer scientist or mathematician, I can list you lots of metrics. Fun working with many of them. Well, it needs to be specific to the problem. The true false or false true in a diagnostic support app can mean very different things. And we need to have maybe multiple combined metrics, how to figure that out. And this needs further work. We haven't yet received input on this aspect. So, to wrap up, this is my pitch. Get involved. Submit your data. The upside is your data could become the reference data set for a targeted health problem, right? If you submit your data and this becomes worldwide known, oh, the Columbia Children's Hospital data have been used here. Great, okay. And then you may also then use this aspect to go to your founder, to a funding organization and say, well, look, this data generation process led to this assessment of an AI method, which then is now used to improve it. Why don't you fund me to do more data generation so we can improve that? And then once we have data, submit your algorithm, right? I mean, that benefit is pretty clear. Once you can show that you actually solve this problem at human level performance, or better than a human, submit your algorithm. And it can be, you're bound to solving a real problem. That means fame and sometimes money. So submit your algorithm. So that's it for me today. If you have questions, if you have pressing questions for what I've said, please ask them now. But you can also listen to Marcel's and the other talks, and then we can have answer questions at the end. Thank you very much.
Thank you. Great presentation. I have a question regarding submitting the algorithm. So how is that compatible with the intellectual property rights? So we submit our algorithm, let's say. What happens with intellectual property?
So the ITU has an IPR policy that is common with the ISO and other organizations. We actually don't ask you to open up your algorithm. It can just stay as a black box. So I don't think your rights are affected. The value of your IP might be affected, right? But not the rights, because we don't have the plan to actually standardize the algorithms themselves. We just publish a document where it would say how good is this thing.
Very cool.
You should use it. And then we have, by the way, we have remote participation. So please use the microphone.
Hi, thank you for a great pitch. So my name is Paul Lee. One question is, what do you think about the transparency issue in AI today? And how do you tackle that as ITU AI for Health?
Can you be more specific on
So-
transparency issue?
Yeah, so we say that the AI today is a black box, and we don't know what's going on inside. When it comes out with a conclusion, how can we trust the data or conclusion that it comes from that?
Yeah, funny you ask. We actually have a research project. Wojtek over there, he has actually come up with an explanation method for deep neural network, where the mathematical function, the nonlinearities are inverted using Taylor approximations, so you can map the classification value to the input, and it can tell you which input contributes most to that classification value. So it's called layer relevance propagation, and I'm saying this as a shameless attempt of promoting our work. But there are other people who also do this, and there is stuff out there where we can understand what the AI algorithm is doing. And I think this becomes more and more important, because when you are designing these things and they are making really important decisions, including your self-driving car going this way or that way, and something happens, you really want to know why it's making those decisions. So there are techniques. They typically require the algorithm to be open. So you need to know the weights of your neural network. Otherwise, you can't do it. Maybe there's a way of running it through a closed algorithm where the weights are not known or the support vectors are not known, but that's a separate question. But there are methods of knowing what these algorithms are doing for specific cases. Whether or not they will generalize, we don't have the probability functions for the underlying processes. They are estimated, right? So we really don't know whether they will generalize. You can only say, at the end of the day, this group can only say, for this data, for this setup, this is what it does. That's it. That's everything this group can do, right? More is not possible. Everything else is speculation.
We do have one question posted. It could be a short question.
Yeah, okay.
Yes. Yes. Does ITU or WHO or focus group have educational outreach programs or plans to fill the knowledge gap that average physicians or clinicians have regarding machine learning application or computer application to computer science in medicine?
We will eventually, once we have created something. We have not yet created much. So with that, maybe we should move on with the session, otherwise we're going to be running late.
All right. Okay, I'm also going to just walk around. It makes me feel, makes it easier for me, and I can see the slides. So thanks everyone for coming. Thanks Columbia University again for hosting us. Thanks also to everyone who's remote participating. So as Thomas said, my name is Marcel Salate. I'm based in Geneva. I run a lab. It's called Digital Epidemiology Lab. This sounds maybe a little strange, but we're doing epidemiology with digital data sources. Can be pretty much anything, but mostly data from social media or Google search queries or Wikipedia access logs or what have you. And the reason why I'm here is twofold. On the one hand, I happened to be at that same meeting that Thomas mentioned, where we sort of spontaneously got together and said we could do something here that could be quite powerful. But on the other hand, I am also running a platform that's called Crowd AI. That's at crowdai.org. I have to say that because there's something else at the .com address where we're actually using crowdsourced AI development. So we're crowdsourcing AI development, and that's working really, really well. And that to me was sort of a really Kickstarter to say, I think we can do similar things here with the technology that we're using and that everyone can use because it's anyways an open source project. And it's reflected a lot on what I'm going to say today. It's based on this experience of running about 40 challenges so far in very different domains. not all of them including health. In fact, only the minority including health. Some involving mapping, some involving transportation networks, and so on. So, see if this works? Yeah. I just want to reiterate what Thomas just said, because I think it's really, in my mind, the most important thing here, which is that modern AI, as most of us know, it's generally based on deep learning. These are the so-called artificial neural networks. These networks are trained on data. The software is now increasingly open. But even though, of course, if you're from a corporation, you may use your own in-house developed software. And with the data, it's sometimes open, often closed. And modern deep learning is end-to-end. That means that there is typically no expertise in between here, but there's just input data, labeled input data, and then some output, whatever that is. And that, reflects the point that you raised after the last talk, that there is a bit of a concern around what this exactly does. But again, to reiterate also what Thomas mentioned, this is not the purpose of this focus group to shed light on this. It has another purpose. So in any case, the consequence of all of this is a great thing, right? This is now a very permissible research field, and I think The Economist recently had a graphic that showed the number of deep learning in the title of academic papers, and this thing was just in an extremely exponential, probably hyper-exponential growth. So everybody can use this kind of approach these days, and everybody does. And that's, on the one hand, that's a great thing. On the other hand, if you come to this as let's say you're a regulator, or you're a hospital or a physician, and everybody's writing these articles how AI is going to replace you, then what are you going to do? First of all, that's not a good conversation starter. But the second is that you also want to know, okay, but so, how does this work? And does it work? And what's the difference between these guys with solution A to these guys with solution B? And so currently there is no established way to do this. And that, in my mind, is really sort of the major gap that this group can fill. And so I call this the Wild West, but I'm a bit unsure these days if that's okay to use or not, but I use it sort of as the, sort of back in the day, sort of anything went, and but nothing is really well defined. Okay, which computer is it? So this, in a nutshell, is then the proposed framework, and I'm going to walk you very briefly through this step by step. I have an explanation for each of those steps, but fundamentally, there's some data here that can be yours, or it can be public data on any medical niche or vertical you can imagine. The idea is that people then train a model, and that's what's currently happening. Now if we set up a process, then the idea would be that people take their models and submit it to a platform that this group would build, or it would use existing platforms. So you would submit code or your algorithm. Your algorithm would then be taken and executed in a safe and secure setting on this undisclosed data set that we are in the process of collecting. So that's one of the major goals of this focus group, to really bring the relevant stakeholders of whatever medical vertical you're thinking of together and say, let's use my data or your data or our data, but we give our good reputation to that we can assure that this is solid data that's been labeled appropriately. And then an algorithm would be executed on that data. As Thomas explained, we will have to define for each case what is actually to be measured, what is relevant for that particular vertical. It would then correspondingly be measured, and those who would submit the model would then get the corresponding feedback. And then this can go on a leaderboard. if we so choose, although that's an option, but we found in the past that, that these leaderboards are incredibly important for psychological reasons. Okay, so just briefly going through each step, but very briefly because I basically already said anything. So step one, we start with the data. As I mentioned, it requires this data as input. We can help identify high quality open data sets to make this more accessible. I think this would be quite important. It's not, I wouldn't say it's absolutely necessary. People are already training their algorithms on the data that they collected, and there's nothing against that. But if we can even make this whole thing more open by providing and collecting and identifying open data sets, I think that would be benefit to the field. Okay, the second is, again, people built their models and submitted them to this platform. And then this is probably the most important and the critical step. So let me just spend 1 minute on this. So there's again, this notion of this undisclosed data set, and that's really important in many ways. It's important, first of all, that this be undisclosed, because any party that would have access to this data set could, of course, completely game the system, which would immediately call into question the entire group. So there's a bit of a concern involved there. How do we do this properly? And we'll hear talks today about ways that this can be done. On the one hand, of course, from a political perspective, whoever runs this thing needs to have the trust of the community. But then also from the technical perspective, can this be done in such a way that it is essentially not able to fail? And also to come back to what you mentioned after the talk, there's often this question, okay, but how do we make sure this black box, how do we make sure this works, this is fair, and what data has been trained on? Actually, it turns out that you can control much of that question by really making sure this is a good data set, right? Because if this is a good data set, first of all, that's good for the quality. If it's a good data set also from a diversity perspective, for example, we hear a lot of issues about bias in machine learning, which is a critical issue. But the critical issue in the bias is not that necessarily your algorithm has been trained on biased data. That's a problem for you and your algorithm. The problem really is that it would be eventually evaluated on biased data set, and people would then say, oh, this works great. But it hasn't actually been tested on a really diverse data set. So we as a community, as a focus group, can really do a lot to issue this, solve is a strong word, but to really mitigate this problem by ensuring we have, we have very good and diverse data sets. So this is just to underline the call for your participation in providing high quality and high diversity data sets. All right, and this I think is clear. So this will be evaluated based on ways that the community again decides is important. Again, we don't want to step in and say this is how you have to measure this. The community usually comes in and says, well, in our field, what matters is the following quantities. And we can say, great, let's define what these quantities are so we can evaluate this according to these quantities. Okay, last but not least, this is the leaderboard. And then again, this can be a continuous and ongoing process. So let me stop here and say, I think this model has a number of benefits. I mentioned most of them now in this talk. But I think what's really great, if we do it that way rather in some hidden fashion, is that this is a really open and inclusive process. So anyone can submit, first of all, algorithms. Anyone can contribute to the data if they have data. And anyone can basically be involved in any part of that wheel that they think their contribution would really be helpful. I think it adds substantial clarity to the field. So again, we're not want to come in here as a sort of sheriffs and say this is how we're going to do it. We want to find this space in the equilibrium where it's a win-win for all. Where on the one hand, academics and industry can come in and say, well, okay, I mean, this looks legit, so why don't I submit my algorithm if it gets this credential and this stamp of approval from this group? That can only be a good thing. On the other side, as Thomas mentioned, the people who provide the data and make sure this is high quality and diverse data set, for them it's also good because it means the data is useful and the algorithms that are developed in their field are working properly. Finally, this whole thing also means it's a really it's an effort that can be easily replicated. So there's no shady business behind the scenes, but anyone can basically come and say, I'd like to see how this has been evaluated. Of course, one cannot disclose the non-disclosed data set, but the whole fact that it has been evaluated according to these criteria in such and such fashion on these machines, of which only these parties have access to and so on, is completely open and transparent, and so it allows for really, great replication. All right, I think that's my last slide, yes. Thanks very much. So again, if there's a pressing question, I'm happy to take it now, but we have 2 other talks, right? And then, okay, but then we can maybe take all the questions at the end. It's maybe easier. Yeah? All right. Who's
So our next speaker is Mr. Samir Pujari. He's a manager and co-founder of the Be Healthy, Be Mobile initiative, and representing World Health Organization. Okay.
Thanks. I don't have any slides. Thank you very much. Thanks again to AIAH for hosting us, and thanks to everyone for coming. It gets bigger and bigger every time. We thought the first one was a bigger one, but this is even bigger, and it's filling all the rooms. So it's great to see this enthusiasm coming in. I think most has been said already. The background, the interest, the approach of doing things. I will bring in from the literature's perspective why this is important and what are we actually looking for. So back in May, when the first the second AI for Good meeting was held, our Director General spoke at the keynote of that session, and it was unique for another UN agency leader to be speaking at a separate UN agency event, and that showed the SDGs coming together, the intentions, the importance of how working together is very crucial. And AI for health has been, AI in general, but for specifically for health, has been a cornerstone for the new Director General, new management, because there's so much potential for putting this to scale. It's not about just doing things and putting it like we had prioritize in the digital health world. This is looking at making an impact at a global health level. I think that's where we are seeing it coming in from. We've seen digital health has scaled up, but the AI's potential to make an impact on the ground is humongous, and that's what we're trying to tap into through this focus group. One of the main reasons why we were part of this focus group and the structure was to avoid the piratitis bug that was hit the digital health world. There's so many great projects that came in, but which never saw the light of the day. They showed results, and then as Thomas mentioned in the beginning, academics do research, present the outcomes, and then finishes. Our job at WHO is to take this evidence that has been published, the great projects that we come out of this AI focus group, and work with the governments to find a business model and a scalable model for these different AI products. So that's why we are very keen on seeing how we can take the actual algorithms, the tools, the solutions, and convert them to impact-making machinery at the ground, working with the government. Now, one thing I think it's important to clarify in this whole process is we're not looking at you donating your algorithms to solutions. That's on the model, as Master has clearly said. It's about funneling one place to bring all together the best practices and finding the win-win situation on business models. Because the governments are now realizing. Earlier this year, in May, all the member states, and this may be a little bit policy-based, but I think it's important to mention this group. The countries, all 194 countries, member states of WHO, signed a digital health resolution, which basically included focusing on AI and institutionalizing these solutions at the government level to make public health impact. What this means is the governments are now committed. They are ready to invest in this space from the goal budget line. So there is an opportunity to work through that angle. They're committed to work with multi-sector approach, not just vertical things, but entire sector, public sector, academic world together. So there is resolution which we can always put on the website and share, but something that is an important political push and that has also motivated in this area of space. I think the projects that we've seen, the 14 district projects, in such a short time already show the interest from the industry side, but the breadth of the sort of the areas of work, mental health, aging, chronic diseases, huge areas, and there's a strong need for having solutions designed for this one. If you can show the evidence, if you can show the impact at large scale level, that's what governments, that's what WHO is wanting to see and make a business case out of. Again, I think the value proposition of this group, and I'm calling it out to everyone. I'm very glad that the Harvard Global Institute is also here, because what we're trying to do is not verticalize AI. It's about bringing all together and see the best impact that you can make in a transparent fashion. So I'll stop there, and that was just the main pitch I want to give from the virtual side. So there is a lot of intentions. Again, thanks all for coming, and we look forward to working with each one of you on doing some specific progressive work on AI. Thank you.
Our next speaker is also one of the management team, Mr. Stevens Ibaraki. He's a social entrepreneur, futurist venture capitalist representing REST Capital, and a founder of the AI for Good Global Summit, and representing ACM.
Yeah, I'm really here to indicate that I represent different global communities, both in business and finance and government, in computing science organizations, and entrepreneurship, venture capital, and so on. So I actually wear chair or founder hats in all of those communities, and distinctly, we are very much interested in what's happening here. We definitely want to support the Pursuit of AI for Health. We think it's an important initiative. Keep in mind that healthcare is about a $9 trillion industry worldwide. That's the value of the marketplace. It's somewhere between 10 to 10.5% of GDP for many countries today. Perhaps a little bit higher, or perhaps a bit lower, but averaging between 10 to 10.5% GDP. So it's a significant area, and AI is a significant initiative worldwide in terms of providing better services and so on, working with the clinicians and others that are out there. So that's why I'm here. I'm representing these different communities, and I'm also encouraging all of you to get involved, to participate, whether you wear an entrepreneurial hat or a funding foundation hat, or whether you're a doctor or you're in the computing science community. You need to get involved in this initiative because it's going to change the world. It's going to make it better. It's going to improve everything that's happening, and it also aligns with the 17 United Nations Sustainable Development Goals. Which, again, will improve the overall outcome of the planet itself. So, as we mentioned, I'm a co-founder of the AI for Good Summit, which is all about value creation to the world and the value of AI from a positive outcome standpoint, which very much aligns with what's happening here. I'm on the board, and in fact, immediately past chair of the ACM. ACM is a very notable computing science organization, and again, I'm on the board of the IEEE as well. I'm on IFIP, and we're very much interested in supporting this initiative from a computing science standpoint because it's so important in terms of moving healthcare worldwide forward. I'm also part of a group called AI Pioneers, which consists of roughly about 100 of the top Fortune 100 companies in AI, represented at a CXO level. And by the way, later on, we have a session from the chair of that, where he's going to speak in this market image, because we are, again, the global Fortune companies are interested in what's happening here and want to support this initiative in every way possible. And again, that's why we're trying to engage you as well in this event. And then also, I come from the venture capital space. So if you're a foundation, which I'm on the board of a foundation, or whether you're in venture capital and investment, this is one of the best areas to get return on your investment, both from a sustainability standpoint, but also from improving the outcomes for the world itself, because of the embrace of healthcare. We also have media interested. There's been articles now appearing in Forbes on what's happening here. So in IDG, which is technology media, the ITU just published a article today, which actually talks about the focus group AI for Health and the importance of this initiative globally as well. So again, if you look at business and industry, government, media, academia, all realize the importance of this initiative, and that's why you all need to become engaged in a positive way, making a positive contribution. So that's all I have to say. Thank you.
We now have some time for open Q&A, so you can raise. And also for the people who are doing remote participation, we are using Pigeonhole. So pigeonhole.at/AI Arabic 4 H Arabic 2. And you can post any questions anytime during the panel discussion.
Hi, good morning. Thanks for interesting presentations. My name is Nina Schwalbe, and I'm at Mailman at the Department of Population and Family Health at Columbia University. I have a question for clarification to Marcel. I've heard the word leaderboard used in golf. Could you explain a little bit how leaderboard, how you're using the word leaderboard and what that means in this context? Thank you.
Yeah, sure. Okay. Thanks for the question. So the leaderboard is something that we've used in our platform that has been used in many of those benchmarking platforms to basically rank the algorithms according to specified benchmark criteria. And so that's been, to some extent, it's been, I think for many of those previous challenges, a little bit of an aspect of gamification. But it's also been really important to sort of for people to see immediately where in the field their algorithm stands in terms of how it performs. But this is sort of, to me, a bit a topic of discussion whether we want to bring that to this group. It's possible that I mean, ranking always can have negative connotations as well, and maybe it's better to do something where we say, okay, I mean, if you reach a certain level of whatever the quantity is, then, you know, for example, you could say, okay, you reach at least this level or that level, rather than saying, oh, of all the algorithms that have been submitted, you have been 7th. So there's certainly some way that this can be defined by this community.
Can I ask a follow-up?
Sure.
So how does that work in health? Are you benchmarking against the standard of care, or it's just purely the algorithm?
Just purely the algorithm, yeah. In this case, it would be purely the algorithm. So that's important, right? So that it's a purely quantitative measure that you can measure based on the data that you have, and that the various stakeholders of a given benchmark agree and say, okay, for us, right, it's this value. And there are many values like that. So, I mean, in many of the classification problems, for example, people have converged on an F1 score that measures sensibility and sensitivity and things like that. In other areas, it could be something completely different. That's really for that particular community of that vertical to say, we need to measure X, Y, and Z, and that's what's then to be ranked. One could imagine, and I think Thomas mentioned this, there are some benchmarks that I've seen that not only do that, but that also then go to physicians in that community and say, could you please do the same thing? So I don't know, many of you have perhaps seen that paper in Nature, I think 2 years or so ago, on the dermatology algorithm that would classify cancers versus non-cancers and types of cancers in dermatology, but they did not just say our algorithm performed at that level, but they went to colleagues at the Stanford University Hospital and said, can you please classify this, so that they could compare the algorithm to the human physician. Could be interesting, could lead to all kinds of potential problems, and definitely something to be discussed also for the group if we want to go there.
I should pick one question from Pigeonhole. I think this could be an orientation question. So the question is about the understanding of the focus group about AI. Is the focus group is more about neural networks and deep learning, or is the understanding of a wide range, including all other models or other applications?
I pointed out, we are only interested in the mapping. How you do the mapping is not our concern. So if you use a Markov model, well, let's just call it AI, that's fine. Doesn't matter. The only thing that matters is that your method generalizes to the unknown cases and has a good performance on that. Which technique you use doesn't matter. And by the way, the term AI has a definition. It's a hyped subject. That's my definition of the AI term, and it covers everything that wants to be hyped.
Yeah, Dr. Reproduceable from the Faculty of Medicine, University of Geneva, Switzerland. Just going back to the point of ranking the algorithms and getting like top 5, top 3, and getting really the spirit of competition to get the very best one. Does it make any technical sense, and I really don't know about this, to combine the algorithms to somehow have lessons learned from one group and another group to actually get a kind of a merged approach based on the top 3, top 5? I mean, to really get the very best, combining the best somehow.
There are some spaces. I've been coming from the space of creating codecs, and that's what happened there. But at this point, we don't have this mechanism foreseen here. At this point, I think we should make our first step towards seeing if the algorithm is better than human level performance on a problem, and if we can document it. And then it's up to the participants, you know, they may not even know each other, and they may be willing to work together and bring it there. I mean, the group is curating these cases. So we have to, you know, first, now we get submissions for use cases. So we get topics. Then we need to look into detail, do these use cases have data? What data? Where do they come from? What about the annotation of the output? Is the output validated? Are these good data? Once we have that, then we can say, okay, for these data, with this reference that you see publicly here, you can submit your algorithm, we'll run it, and we'll tell you how well it does on the non-disclosed data set. And then all of that is several stages and open. And in the course, some 2 or 3 participants or more find the way to combine their stuff. That would be good because it might be better, right? So we say, what's a camel? A camel is a horse designed by a standardization committee.
Okay, just following your comments, actually I am Dr. Shabir from VIP, Vellore Institute of Technology, India. So I want to have a rough idea of how many projects we are going to analyze, and for how long, then what's the next?
Oh, I would like to know that as well.
Yeah. So because we need to know how many projects we are going to call for the project. Yeah. And where we are limiting ourselves, or this will be like forever, or?
So we have these suggestions. Some of them are really far down the road, have thousands of data points available. Some of them have no data available, and most of them are in between somewhere, and they have ongoing reference data creation. Right? How to say? I don't think we want to exclude any topic once we see its value and we see it is ethical to do it. There's no reason for us actually, because we will need to find people who are committed to a topic to drive it, but all these topics will be at different stages of consideration, because we really don't know if data will come for a topic that doesn't have any data. You know, some things people keep talking about forever and nothing happens. So one way of looking at it is to say, well, this list of the subset of topics that we have here is something that we want to work on, and we probably should apply some criteria. And then once we have that, we basically need to ask topic-specific questions, like, you know, data availability, reference data, etc., etc. What needs to be benchmarked? Some of those descriptions are too vague where I don't know what we actually should be doing. We just say, use data to do this and that. We think it's a good thing. So what are we precisely testing? So the time it takes. It's just doesn't matter.
No, that's fine.
It's only really possible if you end the meeting. The form is that it's only really possible to say that if you end the meeting. So I guess I leave it running.
So how long will what's the meaning?
If you stop recording,
For next 5 years, for next.
I'm 48 years old, so I have 21 years to work.
So that is the meaning is like
start again.
Ongoing for next few years.
I can try.
Or
I'll try
I
to
think so.
is there any model
Worst case,
for
it would pause.
sustainability or how we are going to like sustain?
Worst case.
If
Yeah, that's always
if
the
you're-
way. But it would be
Yeah,
great
yeah.
if we can
I think
save
if
it
you're
instead of like I
successful
just.
and you create value, then it's a no-brainer to just keep on rolling and adapting and improving your
I'm just worried about the
process.
size, like it's gonna crash into.
Lots of
If it
people
keeps
are
the
already
RAM, I
quite
don't know
committed to this, and I don't see why we shouldn't. But I see where you're going. But this is a discussion that we are having offline: how to further advance the whole organizational structure of the group, particularly together with the World Health Organization.
Yeah, hi Thomas. Quick question: is it too late to submit a project? I think I realized I might have missed the deadline to submit that list.
So we
still do it, or also the next one? I guess.
we have a deadline for documents typically a week ahead. Then we kind of give some guarantee that we look at the document. The late submission needs agreement from the focus group to be looked at, but I don't think there's a problem if you will submit it. I think that's fine.
The other quick question is, besides algorithms, is there any other area like implementation, best practices, all of that which you folks would look at as far as AI is concerned?
When you do something, so the only thing we have to decide is to decide on what we do with the time that's given to us. Takeaway said that. So we can only create value when we have an actual idea to do it. And I think we are getting too far out on some GPU improved implementation of some algorithm. I mean, it's really difficult to assess complexity of, for instance, algorithms. It's just very complicated. A measurement of performance given a metric in the digital space is something completely feasible, trackable, reproducible. These are all the things that we want to do. Assessment of complexity. I have been around algorithm complexity discussions. I try to avoid these discussions.
We have several questions posted Pigeon Hall. So one question is, does ITU plan to collaborate with industrial corporates like Amazon, Google, since they already have, or they should have, sophisticated frameworks or platforms to develop it?
That's an easy question. Everybody can contribute. They can be contributors, come to the meeting, submit their stuff. They will be treated as badly and as good as anybody else.
Actually, I have actually related to the actually just posted. I'm Xiao He from the Department Secretary. I'm basically working on machine learning using mental health research. So I have a quick question regarding the platform. So, for example, do we have any requirement for training our model based on TensorFlow, or sometimes we build our own model, like deep learning, right? We have our own algorithm, written with C or C++. But TensorFlow is actually like Python-based, right? Or some people use Mandarin. So do we have these kind of requirements? And in terms of the submission, I have a quick question. So, for example, do we need to submit our source code or just submit a detectable, package? And also, that package needs a lot of dependencies. Right? How can we deal with that?
So to be discussed, but fundamentally the model that we're having. Battery. It's a bit early. Fundamentally, the model that we're having for that is executable files, not source code, because I also don't want to see any. I mean, the liabilities of seeing source code. So definitely, sort of, we can use. I mean, what we often do, for example, with AIAH is a sort of Docker-based approach where people basically upload a Docker image and then we can execute that. But that also will depend really on the specifics of each benchmark, how to best do it. But I mean, philosophically, fundamentally, we're talking about executables, not source code.
So unless there
Recording start again.
one last question.
So the approach that's whatever works, so a very benchmark-driven approach, is somewhat different than the approach that things need to be explainable, like pursued by the GDPR. How do you square the circle?
Also to be discussed. But even if you explain a classification result of a machine learning algorithm, you still don't know how it generalizes to other realizations of your random process, right? So, yeah, it could be some step in the future, but that is something that we haven't yet put on our table to also come up with explanations why the algorithm is doing certain things. And it may or may not be a good thing for this group to do. It's we try to get our feet on the ground on this particular task. It's already tough enough. It doesn't work. If we imagine we have 15 parallel projects coming out of this building, how many Yeah.
Okay, thank you for the questions, and let's thank the speakers again. We're going to close this session. And without the coffee break, we're going to